This is Team 3, and here is our horizontal construction design report. Our team consists of Laura Beth Poxtaller, Eugene Abner, and Regina Crenshaw. The project that we decided to examine is a milling and resurfaces project on Greensboro Avenue here in Tuscaloosa, Alabama. It involved a total of 5 sub-activities. We created a model using the Easy Strobe software and determined daily baseline production and unit cost. After performing the sensitivity analysis, recommendations were developed based on the data we collected. The picture shows a Google Maps schematic of the job site area. You can see Greensboro Avenue here running through downtown Tuscaloosa. Due to traffic density and other factors, the site is a bit complex, but simple enough to model with relative ease. The cyclic process involves excavation of the roadbed, hauling dirt away, the application of a tack coat, spreading asphalt, rolling asphalt, and the starting over of the process on the next lane. The constraints that existed within our project were that the curb created by the roadbed and traffic control.
The equipment used in this project were as follows. A Bobcat T190 was used for the scraper and loader. A Sterling LT 9513 truck was used to haul the dirt as well as help in the asphalt spreading. An 8,000 liter DAF LF55 was used as the tack coat sprayer. A Leeboy 8500T was used as the asphalt spreader, and a Cat CS533E was used as the roller. Shown here are example pictures of each type of equipment. Here we have the baseline model that we created using the Easy Strobe software. As you can see, the 5 sub-activities were placed into the model, and each activity shows a queue before it that shows how the activity must wait before it can start. Each resource is also initiated in a queue, and initial baseline values were assigned to each of them. The scraping and spraying of tack coat activities displayed a normal distribution, as shown here. The other activities displayed a triangular distribution. According to our Excel calculations, we determined cost and production for our baseline conditions. Shown here is a partial report from the Easy Strobe software. Also shown are our cost and production calculations from Excel. The total cost was $9,281.12 per day. The unit cost was $9 per cubic yard. Total production was 1,031 cubic yards per day. The model was validated because the times that were generated were shown to line up with the site observations that we took during our visit.
After calculating the production rates, the cost estimation was done to compare equipment costs, operator costs, and total cost. The sensitivity analysis included ways to optimize our model. We used a trial and error approach and calculated the new production rates, the new total cost, and the new unit cost. And here you can see in our table where we put in different scenarios to compare the production rates and the unit costs to see how they vary based on the scenarios. So to conclude this process, we came up with recommendations to improve our model and ultimately improve the real-life project. Our recommendations are to add 4 asphalt dump trucks and 1 loader. This will reduce the cost from $9 per cubic yard to $6.74 per cubic yard, which is a 25% reduction. And respectively, this will increase the production from 1,031 cubic yards per day to 1,961 cubic yards per day, which is a 47% increase. Thank you for your time.